Okay, so I don't know if you need more paper or not. I was able to squish everything on this part of the review, but it was definitely a little tight. So some of the problems I will put on a different piece of paper. But for the first three, I'll just keep them on this paper. So the main thing is if you have a constant, that means you're going to loop. And we will have written this in class. It means you're going to loop. And C, constant means, C means constant. There's a loop. And it means change a base. Not always, but you'll know when it's change a base, unless your calculator has that option where you don't have to do that. That's that math button. So first row, this has a constant, this has a constant. So this one doesn't, so I just need to make it so that the bases are the same. And the base between 5 and 25 is just 5. So the left side stays the same. And if I rewrite 25 as 5 squared, I still have 25 to the x minus 5 power. And now that my bases are the same, I can ignore them. And I can focus on the exponents. And just when I actually get to that solving part, remember, I have to ask myself, should I factor or should I not? So this is the same type of x. I'm just going to distribute the 2 over on the right side. And now I'm just going to work to get x by itself. So I'm going to subtract this x to over here, so I just get 1x or x. And I'm going to add this 10 to over here. So when I add 10 to this -3 or -3, I get 7. And now that I'm done with that, I have x equals 7 as my answer. All right, so this one has a constant. So a constant means I'm going to loop, but I can't loop until it's just the base and the exponent. And that's all that's here, so I'm ready to loop. Just don't loop it into an exponent. So it's going to go log 3 of 7 equals x. So some of you can use the math button. Some of us will have to do the change of base formula, log 7, close your parentheses, divided by log 3. You can also use ln. And whatever that's worth, that's my x. So if I type this into my calculator, I do get 1.771 for x. Okay? So this one also has a constant, so I will be looping it, but this is the base with its exponents. I need to move the 7 and the 2 over. So first I'm going to add the 7. That gives me 12. Then I'm going to divide by 2. That gives me 6. And now I'm ready to loop. And log with the base of e is just ln. So it's going to go ln 6 equals 2x. This is where anyone can use your calculator and just type in ln of 6. So I'm going to go 3 decimal places, so 792. Let's put it over here. And that equals 2x. And now to get x by itself, I just divide by 2. And when I'm done, here's my answer to 3 decimal places. Okay? All right, next row. Do I loop or do I not? No constant, constant, no constant. So again, for this problem, I need to get it so that the bases are the same. The common base between 6 and 36 is 6, so I will leave the left side alone. Its power is x squared. I will rewrite 36 as 6 squared, so I still have 36 to this power. Now that the bases are the same, I can ignore them and just bring the exponents along. When I look at this, I see more than one type of x, so I will have to factor, but first I'm going to distribute that 2 in. And then to factor, I need to bring everything to one side, and factoring is easier when your leading term is positive, so I'm going to add the 4x over, and I'm going to subtract the 12. So when I'm ready to factor, this is what I'll be factoring. So I just need the factors of negative 12 that get me to 4. Those factors are 6 and 2, with 2 being negative. And then I'll have my parentheses of x plus 6 and x minus 2. And then my solutions are negative 6 and 2. All right, so that's number 6. Or 21, sorry. So 22 with the constant, I will need to loop, but I can't loop until it's just this base and exponent, so I have to move the 2 and the 9. The first thing I'm going to move is the 2. Since they're dividing by 2, I'm going to multiply by 2 on this side, which will cancel this out. And I'm going to multiply this side by 2, which will turn it into 30. And now to get the base and the exponent by itself, I'm going to subtract the 9 over. It gives me 21. And now I'm ready to loop it into a log. So it's going to go log with 7 of 21 equals 5x. Again, some of you will need to use your change of base formula, so log 21 over log of 7. So when you type that into your calculator, you get 1.892. And then I still have the 5x over on the right side. So now to get x by itself, I'm just going to divide by 5. And I'm really running out of room here, so I'm going to squish my answer here. So when I take 1.892 and I divide it by 5, I get this as my answer, 0.378. And I've already done this work, so you guys should be practicing this on your calculator. Okay? All right, next problem. No constant, so I don't have to loop. I just need one log on one side, one on the other. That's good to go. So at this point, this becomes my math problem. I do not need to factor. These are the same type of x, so I'm going to subtract the x over here. I'm going to add the 4 over there, and when I'm done, I get my answer. It's 10. All right, let's go to 24. So I do have a constant. I will be looping, but I can't loop until it's one log. So I will have to condense this side down, and 3x squared plus 3 will become 3x squared times 3. So that's 9x squared. This is not your problem. Don't forget, you still have to bring the log back. Okay? Now that I brought it back, I'm going to loop it into an exponent. So 3 to the second power equals 9x squared. Moving over here, 3 to the second power is 9. I can just get x by itself. It's one type of x, so I'm going to divide by 9. And then when I take the square root of x to solve for x, or the square root of 1, remember you get two answers, positive and negative 1. All right, let's go to number 25. So this one has a constant, so I will be looping. It's just one log. It's ready to loop, so I'm going to take 2 to the second power equals all of that. And because there is more than one type of x, I'll be factoring. First, I'm going to turn this into 4. And then I'm going to bring the 4. I'm going to subtract the 4 over to join this subtracting of 6. That'll give me a 10. So now I just need those factors of oh, my mistake. Sorry, I forgot. In class, we did turn this into a plus. I forgot that. I did not make that note here. Okay. So when I bring the 4 over and I subtract it over, I'm actually going to have a 2 here. That's my mistake. Sorry about that. Okay, so now I need factors of -2 that get me to -1. So 2 and 1 will do the job with 2 being negative. So then I get x minus 2 and x plus 1. So what's going to make those 0 are x is 2 and x equals -1. All right, let's wrap this up. So 26. Again, I have a constant, so I will be looping, but I can't loop until I'm down to just 1x. So I will condense the side, and this 3x adding this log over here, this will turn into multiplication, which I can distribute in. So I get 3x squared minus 3x. There's the right side. Don't forget to bring the log back. Oh, that's a little 6. Anyway, it's ready to loop. 6 to the third power equals all of this. Six to the third power, that's 216. And then when I look at how to solve this problem, I have more than one type of x, so I'm going to factor. I'm going to bring the 216 over here. Write it up here. And factoring, the first thing I notice is I can take a 3 out of all of these, so I'm going to take that 3 out. That's going to leave me a 72 here. Here's the 3 that I took out. And now I'm still factoring this part. So what are factors of -72? They get me to that -1. That'd be -9 and 8. And now there's the 3 that I took out. I'll have x minus 9 and x plus 8. So what's going to make these 0? Well, that'll be 9 and -8. The 3 has nothing to do with it. I'm looking to what makes my x 0. So there's 26. All right, the word problems. There are word problems on the test, so don't be freaked out. What they'll be doing is they'll be giving you the formula. Here it is in this problem. and they're going to tell you what all these things mean. And sometimes you can type it all into the calculator, and sometimes you'll be solving. You'll just have to kind of figure out, which one of those it is. So it says the wind speed, S, that's in miles per hour, near the center of a tornado can be modeled by that equation. So S is the speed, and D is the distance in miles that the tornado travels. And then in 1925, a tornado traveled, so that's my D, 220 miles per hour. So estimate the wind speed. So we'll be figuring out what S is. So just put 220 into there. So it's 93 times the log of 220. And then I'll be adding 65. And the great thing is this base is 10. I can type this whole thing into my calculator to get that. So any calculator, you'll type it in the same way. So if you can kind of see, I'll be typing in 93 times, that kind of looks like a subtraction sign. So it's, okay, 93 times log, just the regular log button, 220. Close that up though, plus 65. And there's my answer. So it says, well, it doesn't say how to round it. So 282. I'm just going to make this one 283. All right. Oh, no. Sorry. I started writing. So I'll round it that way. Miles per hour. That's the speed. Again, 93 times log 220, add the 65, and you get your answer. Okay, next one. So they give us the equation. So you're driving on a hot day when your car overheats and stops running. The car overheats at a temperature of 280 degrees. And when it's 80 degrees Fahrenheit outside, the cooling rate of the car is, there's our rate, and it's already as a decimal. If you can drive again once the temperature of the car is 230 degrees, how long do you have to wait until you can continue driving? Using Newton's law of cooling, use the equation below to solve for T. Everything has been set up for you. They took all these numbers, put it in for you, so you just have to solve for T. This is an exponent problem. It's very similar to 18 and 19 and 22. So I will be looping it into a log because I have some constants, but I can't loop it until it's just this base with that exponent. So I'm going to have to move the stuff away from it. So first, I'm just going to take the 280 and the 80 in the parentheses and subtract that down. Hopefully I don't leave out any zeros. And now to get the base, again, and the exponent by itself, I'm going to subtract 80. So when I subtract 80, that gives me 150. And now to get by the base by itself, I have to move the 200 since it's multiplying. I'm going to divide. And typing that in my calculator gives me this decimal over here. Whoops, I forgot my T. And now it's just the base and the exponent. I'm ready to loop it. So it's an exponent. It's going to be looping into a log. Log with a base of E is ln. So it's ln of this equals that exponent. And now to get T by itself, just divide. The main thing is when you type this into your calculator is after you type ln 0.75, don't forget to close the parentheses. So when you do that, your T ends up being, what was it, about 49.6 hours. All right, let's see, last problem. So the length L in centimeters of a scalloped hammerhead shark can be modeled by this function, where T is the age, L is the length. So how old is the shark that is 175 meters long? That's going to be my L. And again, can I just type it into my calculator? That's a minus sign. Or am I looping it? Well, since this is the exponent, I'll be looping it. And so what I'm going to have to do is get this base and exponent by itself. Sorry, that's a little messy there. So the first thing I'm going to do is I'm going to move the 266. It's a positive 266. I'm going to subtract. So that's going to give me negative 91 over here, equaling this. So I'm going to add the opposite here so you see that that's a negative 219. Now to get the base and the exponent by itself, I'm going to divide by this negative 219. When I get that, I get a decimal, but I just rounded it to 0.416. And now it's ready to loop. It's an exponent. It's going to loop into a log. So log with an E is ln of that number towards and around the equal sign equals my exponent. Type in ln of 0.416 in your calculator. You're going to get this. And here's the other side. I know I'm really running out of room. And now to get t by itself, since these are multiplied, I'm going to divide. And when I divide that in my calculator, my t is 17.5 years. Okay. All right, so in this last part, the inverse part, on the Chapter 5 test, if you go to PowerSchool, check out your grade, I will make part of this be the retake. So if you don't want to do the retake portion, then if you just focused on the bottom part, this would be the portion that you would be focusing on when you took your test. So the first part of this is going to include the review for all those people. You can fast forward if you don't need to do this. So I need to find the inverse, and I do need to state the domain of the inverse. And domain has 3 areas that you have to worry about. Those 3 areas are, let me get some blank paper here, is if you have your variable in a denominator, because your denominator, that's supposed to be an n, cannot be 0. If you have your variable in an even radical, because you can't take the even root of a negative number, so what's in there has to be 0 or bigger, or maybe you have the 2 of these happening. Sometimes you're not going to have any of them happen, so that means you don't have any issues with your domain. You can let it be all real numbers. And the domain just means if you were going to make a t-chart, what numbers would you never include in your t-chart? Which ones would give you an issue? You'd get an error message basically on your calculator. So in all problems, to find the inverse, what you have to do is switch your x and y around. The first one is not in terms of x and y, so what I did is I just turned this, into y, and I turned this into x. So the first thing I'm going to do is switch my x and y around. So there's x, and now my job is to get that y by itself. So the first thing I'm going to do is get rid of the 3. If they are dividing by 3, I'm going to multiply by 3. So multiplying by 3 here, multiplying by 3 here. So on the left side, I have 3x equals negative 15 plus 7y. And now to get y by itself, I have to move the negative 15 and the 7. So first I'm going to add 15. So it's going to give me 3x plus 15 on the left side, 7y on the right. And now to get y by itself, I'm going to divide by 7 here, and I'm going to divide by 7 here. So when I'm done, here's my inverse. Y equals, there's the y equals that. So 3x plus 15 over 7. So now I want to ask myself, do I have any of these domain issues? Do I have x in a denominator? No. I have 7 in the denominator. Do I have x in an even radical? No, I don't. So my domain here is all real numbers. All right, next one. Again, I need to find the inverse. So this is y. So real quick, I'm going to switch x and y around. And what I need to do is get this y by itself. So first, I don't like the fraction, but I'm going to move the 3 first. So I'm going to subtract 3 over. So now it's x minus 3 equals this. The next thing is I don't like that being in the denominator. So since it's in the denominator, to undo that and they're dividing by y plus 2, I'm going to multiply by y plus 2. So that'll cancel that side out. And that means I'm going to be taking this side, I'm going to wrap it in parentheses, also times y plus 2. And I'm not going to multiply them. I'm just going to leave it as y plus 2 with this x minus 3 equaling 1. And now to get y by itself, I have to move the 2 and this. So since all of this is multiplying to this, I'm just going to divide by the x minus 3. Those cancel out over here. Divide by x minus 3. So at this point, I have y plus 2 equals this. And now to get y by itself, I'm going to subtract 2. So I'm running out of room. I'm just going to write it like this. Here's my inverse. So do I have any domain issues? Do I have x in a denominator? Yes. what will make that denominator 0? I do not want x minus 3 to equal 0. So if I just add 3, here's my domain issue. I would never pick 3 as far as that one goes. Okay, so here's the inverse, and here's the domain issue. All right, let's go to this one. So again, this is like y, this is like x. So switch them around, and I need to get that, y by itself, and I can't until I can get in that radical. So to undo a fifth root, I will take it to a fifth power. That cancels that out, which means I'll be taking x to the fifth power. Okay, and now to get y by itself, since they divided by 2, I'm going to multiply by 2. So here's my inverse when I'm done. It's y equals 2x to the fifth. So do I have x in a denominator? No. Do I have x in an even radical? No. So this domain is all real numbers. All right, number 4. So again, this is my y. So I'm going to switch x and y around. And my job is now to get this y by itself. So first I'm going to add 1. And now to get y by itself, I have to move the cube. So I'm going to cube root this side, undoes it, cube root this side, all of it. So I'm at this point now, cube root of all of this, equaling y plus 1. And now to get y by itself, I just have to subtract the 1 over. So when I'm done, I'll have the cubed root of x plus 1, and then outside of that will be a minus 1 equaling the y. Now as far as the domain goes, do I have x in a denominator? No. Do I have x in an even radical? No. This is an odd radical, so this one's okay. So my domain is all real numbers. Just for the sake of practice, if this had been the fourth root of x plus 1, remember, this can't be a negative number, so what I want in here has to be bigger than 0 or equal to 0. And then I could solve for x and subtract the 1, and then it would be, this would be my domain. I could pick -1 and anything bigger than -1. But that was not the case for this problem because it was a cube root, but I do want you to see that. Okay, state of the functions are inverses. So I'm going to go ahead and tell you this one's no, and this one's yes. And we're going to do this one first because I want you to see how easy this should be to figure this out. And the idea is you're going to use composite functions, and if you take g and put it into f, or f and put it into g, and simplify it down, you should get to x. So I'm going to, for this one, take g, I'm going to take all of this, and I'm going to put it right there into that x. And when I simplify it down, I'll end up with x. So the 2's still there, but x is coming out, and I have 3x minus 4 over 2. And the plus 4 is still there, and the 3 is there. And what should happen is this should all simplify so that when we're done, we just have the x. Okay? Whoops. Hold on. 3x minus 4. Yeah, okay. So the first thing I'm going to do is clean up this numerator. So if I take 2, or 2 over 1, times this fraction, these 2's are going to cancel out. Okay? So the 2's are going first. That leaves me with 3x minus 4 plus 4 over 3. And you can't just cross out everything but the x's. You have to do the steps I'm taking. So I'm still cleaning up the numerator. Now the 4's are going to go. So when I'm done, I just am left with 3x over 3. Then those will cancel out, and I just get 2x. So the 2's, then the 4's went, and then the 3's went. So when I go about it for the other way, I should see the exact opposite. So this time, instead of taking g and taking it into f, I'm going to take f, and all of this is going to go right in there. So the 3 will still be there, the minus 4 and the 2. So here's the 3. Instead of x, I'll have this. I still have the minus 4 over 2. All right, so again, the first thing I'm going to do is clean up this numerator. This time, when I take this 3, or 3 over 1 times this fraction, the 3's cancel out. They were the last things to go in this one. They are the first things to go in here. So I can squeeze this here. So in the numerator, I still have 2x plus 4 minus 4 over 2. The next thing is the 4's will go. So working backwards, the 3's went, now the 4's are going to go, and I'm left with 2x over 2. And where the 2's were the first thing to go here, they are the last thing to go here, and you're down to just x. And it should work that way. If it doesn't work that way, then they're not inverses. And that's what you're going to see here. So are these inverses? Well, let's take G and put it into F. So all of this is going to go right in here. So I'm going to have negative 4. The x is gone. I'll have 4x plus 8 over 5. And then the minus 20. And all of that's over 5. So the first thing I want to do is to multiply the fractions. These are not canceling out. So what I'm going to have to do is, since there's no simplifying theirs, I'm going to have to multiply this 4 in. So when I do that, I get negative 16x plus negative 32. All of that's over the 5. And then minus 20, or 20 over 1. And then that's all over 5. These 5s don't cancel out. Even if you think they did cancel out, there's no way this is turning to x. If anything, I have a fraction here that I need to subtract with the common denominator. So if this is 5, I'm going to make this one be 5. So if I multiply both of these by 5, I get this. And then negative 16x plus negative 32 minus 100. I can take the negative 32 minus the 100 and get this. If you can see, that, I mean, nothing's canceling out. There's no way this is going to get to x, so I'm just going to stop here. And if it doesn't work one way, it's not going to work the other way. So this one goes really smooth. This one doesn't, so just stop. All right, so what's going to be on the actual test that everyone has to do is this: find the inverse. So the inverse means logs go to exponents, exponents go to logs, so I'll be looping, but I can't loop until it's just the log or just the exponent. So first step, always switch x and y. And now this is my log. I'll be looping it into an exponent, but first I have to subtract the 7 over. And then I'll loop it, and hopefully I'm done. So it goes 5 to this power equals y. So if you think about it, this 5 is growth, this 5 is growth. This says move up 7, this says move right 7. Okay, number 8. So this is another log problem. You can switch x and y. And this is all part of the log, so it's ready to loop. So I'm going to go 5 to the x power equals all of this. And now to get y by itself, I still have to move the 2 over, so I'll be subtracting it over. And here's my inverse. So this is a base of 5, this is base of 5. This says to go left 2, this says to go down 2. Okay? All right, number 9, inverse. So switch them around. And again, I can't loop this log into an exponent until that 6 is gone. So I'm going to divide by 6, which instead of dividing by 6, I'm going to write it as 1/6 times. Okay? And now this is gone. And this has a base of e, so it's going to go e to this power equals y. And the reason I did that is because if you were going to graph this one, e to the 1/6, you have to see if that's really worth or bigger than 1 to know your shape. So, but you could have x over 6, that would be fine. All right, 10. Here's my exponent. I'm going into logs now. So first thing before I can loop is subtract, well, after switching, I'm going to subtract the 5 over. And now I'm going to loop it into a log. So it's going to go log with this base. So go towards the equal sign and around it of all of that. I will wrap it in parentheses. And that's going to equal y. And there's the inverse. All right, 2 more. Okay, so it's an exponent. I'll be looping it into a log. Let's switch x and y around. And again, I can't loop it until this base and exponent are alone. So I'll move the 2. They divided by 2. I'm going to multiply by 2. Now I am ready to loop it. It's an exponent. It loops into the log. So log base 5 of 2x equals that y. There's your inverse. And the last problem. Okay, so inverse. Switch them around. Again, it's an exponent. I will be looping it, but not until it's just that base and exponent. So I got to add the 2 first. And now it's going to loop. So log base 6 of all of that equals the y. And there's your inverse. And that is your review.